So these are the three handouts that I want you to do for relating to Venn diagrams, just to give you some extra practice. These three types of things will be on the test. So what we have here is we have three sets, A, B, C, A, B, and C, and the numbers represent the number of elements that are in each part of the shape. So circle A consists of this shape, this shape, this shape, and that shape. So, and there are 8 elements that are in this part, 3 that are in this part, 1 that's in this part, and 4. So if I asked the question, what are the number of elements in set A, I would add these 4 numbers together, 8 plus 3 plus 1 plus 4, which would be 16. And if I asked you the number of elements in set B, it consists of these 4 different shapes. So the number of elements in set B are going to be 3 plus 2 plus 0 plus 1, which is 6. And the number of elements in set C, here's set C, it's this circle. So it consists of these 4 pieces. 4 plus 1 plus 0 plus 2, which is 7. You could also look at the intersection of two sets, the number of elements in the intersection of A and B. So this football represents A intersection A and B, and you can see I've got 2 numbers that are in that. So that would be 4. A intersect B is this football, 3 plus 1. If you did the intersection of sets A and C, it's going to be this overlap football. So the number of A intersect C is going to be 4 plus 1, which is 5. And the number of elements of the intersection of B and C, that's this football shaped area. And you can see I've got 1 and 0, so that's 1. Okay, now what I'm going to talk about is the intersection of three sets, or the complements of sets. So we're going to start off, and this is what I want you to fill out. You'll need to print 2 copies of this this particular handout. It has 4 on one side. You need to do both sides. So the first thing we're going to do is just going to look at the intersection of 3 sets. So if you have A intersect B intersect C, the place where all 3 circles are, where they overlap, is this center part. So you can see this is in set A, it's also in set B, and it's also in set C. So that's the intersection of all 3 sets. So go ahead and write this out, mark those things. And if I ask the question, what are the number of elements associated with this, it would be the number inside that little football. So the answer is 1. Okay, so that's the easiest one. We did A intersect B, which was these 2. Next what we're going to do is we're going to look at, let me move this down just a little bit. So the next one we're going to look at is the case of A intersect B intersect C complement. And ultimately we want to know what the number of elements in that are. And what we saw earlier was that you can replace the intersection with C complement as subtraction. So instead of intersect C complement. So the way we do that is we do the first thing, which is the intersection. So A intersect B is this part. So that's A intersect B. And then we subtract C. So the part of these 2 pieces that's A intersect B, the part that's in C is this. So we get rid of that. And what that leaves, if we get rid of the C part, it leaves this little shield thing up here. So the number of elements that are in A intersect B minus C is that part. So the answer would be 3. And we have 2 that are similar to that. You just change the order. So the number of elements in A intersect B complement intersect C. So what you can see what I've done is I have put the complement on set B instead of set C. So what we can do is we can change the order of the sets. It doesn't matter which order we do these. So I'm going to do A intersects C and then move the B complement to the end. And then we make the replacement that the intersection of the complement is like subtracting it. So again, we're going to look for the intersection of A and C. Here's A, here's C. So this is A intersects C. And then we erase the C part, the B part. So that leaves this little doohickey thing here, right there. So instead of this being, it's the same shape, but it's over here. So the number of elements that are in that green cross-hatched area is 4. And the one we haven't done is this one. So we've done that one, that one, that one. We're going to do the next one. So if we look at the number of elements in the intersection of sets A complement, B, and C. So first one was C complement, B complement, now it's A complement. So you can change the order. B intersects C, intersect A complement. So just move that to the end. So you can see what we're going to do is we're going to take the intersection of B and C. Here's B, here's C. So that's B intersects C. B intersects C. Then we subtract A. So we erase the part that's in A, and that gives us the third shield area. So the number of elements, and again what we did was we replaced the intersection with the complement. So that's the last thing with subtraction. So we did B intersects C, erased A, so the answer is 0. So we've gotten this one. This is the intersection of all three. This is the intersection of A and B minus C. This is the intersection of A and B minus A and C minus B. This one's the intersection of B and C minus A. Okay, now we're going to go, we've got 3 that are very similar. We're going to have the intersection with 2 complements. So let's do the number of elements of A intersect B complement intersect C complement. So now we've got 2 complements. It's already in the right order, A, B, C. Well, actually what you're looking for is you want the set that is not a complement first. In this case, it's A, so it's in the right order. And then you replace intersect B complement with minus B, and then intersect C complement with minus C. So instead of starting out with an intersection, we start out with an entire set. So set A would be everything in the circle A. Okay. So that's set A. Then we subtract the stuff that's in set B, which is that. So that's the second part. And then we subtract the part that's in C. We've already taken care of that middle part, so we don't have to do it twice. So what that leaves is that little shape, whatever that is. And so the number of elements that are in A minus B minus C, which is the same as the original one, is going to be 8. So that's the first one. We do this one and that one. And from a survey standpoint, they are for a minute there, I thought I wasn't recording. This is people who like A but don't like B or C. Okay, so let's do the next one that makes sense. So we'll start off with We'll still do it in alphabetical order. So we'll go A complement intersect B intersect C complement. So now instead of A being the set, it's B and being the set. And then we change the order, so it's B intersect A complement intersect C complement. And then we replace the intersection of the complement with the subtraction. Okay, so let's go ahead and, so we fill in circle B. Now since you can't erase stuff, probably the best thing to do is just to think about, maybe do it lightly in pencil, and then you could just do the final answer in darker. Okay, so there's set B. Subtract the part of that that's in A, which is those two. So now those two are in A, and then finally we subtract C. We've already taken care of that part, so we just have to do this extra part. So that leaves that part right there. So the answer is 2. Then we have the number of elements in the intersection of A complement, B complement, and C. And again, I can change the order. So it's C intersect A complement intersect B complement. And then I can replace the complement with subtraction. And we want to figure out the number of elements. So again, we start off by filling in C. That's our first term, which is not subtracted or not intersect with the complement. So that's that part. Then we take our eraser, subtract the stuff that's in A, and then subtract the stuff that's in B. That leaves this little bit right there. So the answer here is 2. So we had 8, 2, and 2. And then the final one is where we have the intersection of the 3 complements. And basically what is happening there, that's when you have all 3 complements, it's everything that's outside of the circles. So you have to think about that. Complement intersection of all the complements is all the stuff that's outside of all the circles. So we don't have to do any, we just have to remember that what that is. It's this outside part. So what number is there? The answer is 6. Okay, so that's that one. I want you to turn that into your next test, and we'll count it as towards your homework grade. Okay, the next one is I give you the numbers, and then you have to fill out the Venn diagram. So it's kind of the opposite of what we just did, except we have to, we did one of those in the lecture. So if you watched the video, you should have seen this. I can't remember where actually this part 1 actually might be in the video already. Anyway, I'll work it out for you. If you've already seen this, you don't need to do it again. Or you do, but you need to fill it out on my handout. So these are the 3 sets, A, B, and C. So the way this works is you always start off with the intersection of all 3 things. So that's this one. So that's the first thing to do. So the intersection of all 3 is this one in the middle. So that's 5. The next thing you go to is the intersection of 2 of them. So here's an intersection of A and C. This is an A, B complement, so we can't use that yet. B intersects C. And you'll see that there's no other, there's a union of B and C, there's the intersection of B and C complement. So those are the next things that we can do. So when you have an intersection of 2 things, you usually have 2 numbers, 2 parts you have to worry about. So the intersection of A and C is these 2 parts. And you can see I already have 5. So to get 13 total, I need to put 8 in here. 8 plus 5 is 13. That's the total in that football, made up of 2 parts. And typically, there's only 2 things you can just, well, 3 things that you could put in directly. The intersection of all 3. This one, which is going to be the intersection of 2, subtracting the third one. And you could also maybe do the intersection of all the complements, and that would come out here. But the other ones usually have to do some subtraction. So if you're not doing subtraction a lot, you're probably doing it wrong. Okay, so that one's done. Intersection of B and C. Here's B, here's C. So these 2 are part of the intersection. The total has to be 8. I've already got 5, so that means I put 3 there. 5 plus 3 is 8. So we did subtraction there. 8 minus 5 is 3. Now we don't have the third intersection yet, so we can't do that. So now we look, when you have the number of elements in a particular set, you need to know 3 out of the 4. In this case, I know 2 out of the 4. Here I know 2 out of the 4 that make up B. And I know 3 out of the 4 that make up C. So if I knew the number of elements in set C, I could put that in directly, but I see that's not part of the whole thing. We've got this one, which is the intersection of all the complements. So that's easy. That just goes outside. So if you ever have the intersection of all the complements, just put that out. Now, this, remember what that is. That's well, let's just kind of see if we can figure out what these are. So the intersection of A and B complement, that's the same as A minus B. So if we took A and we subtracted B, it would leave just these 2 elements, these 2 parts. So we take, let me just cross these hatches. So this is A. And then if we subtracted B, it leaves these 2 parts. And that has to add up to be 9. So from that we can say this has to be 1, because A minus B leaves these 2. That has to add up to 9. Therefore, 1 plus 8 is 9. Okay, so we did that one. Probably this one, similar kind of deal. B intersects C complement, which is the same as B minus C. So here's B. Subtract C. Well, that doesn't help. That leaves 2 of those things. So we can't do that one yet. What else do we have left? Oh, okay. Well, the number of elements, we go to this one. The number of elements in A is 15. So now we go back. Once we did this one, we got one more additional piece of information. So this plus this plus this plus that, that's everything in A, has to add up to 15. So how much do I already have? I've got 1, 9, 14. So that means that has to be 1. 1 plus 8 is 9, plus 5 is 14, plus 1 is 15. Okay, now what have we got left? We got 2 spaces, so we can, this is this one, and there's this one. So let's try this one again. B intersects C complement. It's the same as B minus C. So I just have these 2 left. B minus C. So that has to add up to 3. Well, I already have 1. So this one's 2. Again, you can see, let me just mark that off and I can erase it. So you get B, that's set B, minus C, left these 2. And those 2 had to add up to 3. So that's why I put a 2 there. And finally, I can use the union of B and C is going to be 32. So this is C, this is B. The only thing I have left is that. So I have to add 6 numbers together. 1, 2, 3, 4, 5, 6 to get 32. Or I can add, what I can do is add what I've got already. So that's 1, 2, 5, 3, and 8. So it's 1 plus 2 plus 3 plus 5 plus 8 plus x equals 32. So if you add all these together, 8 plus 5 is 13, 13 plus 3 is 16, 18, 19. So x equals 32 minus 19, which is 13. And now we got everything filled out. So let's double check everything. Number of elements in A is 15. We already did that. The number of elements in the intersection of all three is 5. The number of elements in A intersects C, which is here, is 13. The number of elements in A minus B, A minus B is 9. Those add up to 9. Intersection of B and C has to be 8. So this is football. 5 plus 3 is 8. This is everything outside. B intersects C complement is the same as B minus C. So I take B, subtract C, that leaves these two to add together. They add to 3. And then B union C is, when you have a union, you add 6 numbers together. So if I had B union C, I add these 6. If I had A union C, I add these 6. There's only one that's not in A or B, and that's, A or C, which is this one. Okay, so that one is maybe a little harder than it's going to be on the test. And then the final one is taking these words and filling out the Venn diagram. So we've got 3 kinds of food. We've got Indian food, we've got Mexican food, and we've got Thai food. So we start just like the previous problem, except the information is given in words. In this case, it's in a kind of an opposite order, but not an opposite order, but it's you have to look at them. And the first thing you look for is the intersection of all 3. Well, that's when people like the same thing. So in this case, 5 people like Indian, Mexican, and Thai food. So that's the first thing we do. And that goes right in the middle part again. The next 3 are liking 2 out of the 3. So these are the footballs. Indian and Thai food, that would be this area. Indian and Mexican would be this. Actually, we've only got 2 out of we don't have Indian and Mexican and Thai food. So we're going to be able to use these 2 second because they're the intersection of 2 things. So 12 people like Indian and Thai food. So here's the football. It has to add up to 12. So that means this has to be 7. 7 plus 5. Okay, so we got that one done. We got this one done. Indian and Mexican, that's this football. Has to add up to 8. We already got 5. So this becomes 3. 3 plus 5. The football is 8. Okay, then this would be, we can do this third. 40 people like Indian food. Here's the Indian circle. We know 3 out of the 4. So to get the what's remaining, you take this plus this plus this and subtract it from 40. So 7 plus 5 is 12, plus 3 is 15. So you take 40 minus 15, which would be 25. So 25 people that like Indian but don't like Mexican or Thai. Okay. 37 people like Mexican food. Well, notice we've got 2 unknown things here out of this circle, so that's not going to help us any. Same with if we knew the Thai food, we wouldn't be able to fill that out. So we're going to skip that one. This is an or. That's usually lasts. Now this one we can actually do directly on the graph. 12 people liked Mexican and Thai, so that's the football here, but didn't like Indian food, so we'd erase that. So you'd have this football, but remove the people who don't like Indian food. So we can write that 12 indirectly. So that's the only time you can, besides the intersection of all 3, is if you like 2 but not the other. That's going to be one of these 3. This 7 like Indian and Thai food but not Mexican. and this would be Indian and Mexican, but not Thai. So that helps out a lot because now, so which one did we use next? We used this one, 4. Now we can go back. 37 people liked Mexican food. So here's Mexican food. This plus this plus this plus that equals 37. So we'll take 37 and we'll subtract the other 3, add it together. So 5 plus 3 is 3 plus 5 is 8 plus 12 is 20. So we subtract that. So we get 17 in here. And then we can use the OR, the last one, next to the last one, 6. 54 people liked did I miss something here? Either Mexican or Thai. I don't know where that disappeared. So this should be or Thai. Organ, yeah. So again, this is the only one I don't have to consider. So I'm going to add these 5 numbers together. So 17 plus 3 is 20, plus 5 is 25, 35, 37, 44. So these 5 numbers together are 44. So I'd take 54 minus 44 would be 10. So 10 would go there. And to find the number outside is you take the number of people that are surveyed and subtract the sum of the remaining 7 numbers. So you can do this calculator-wise. What I'm doing ahead. 25 plus 3 is 28. 20 plus 5 is 33. Plus 7 is 40, 50, 60, 62, 72, 79. So you add these 7 numbers together, you get 79. So if we take 100 minus 79, we get 21. I'm just waiting for my cursor to work again. Oh, there we go. So 100 minus 79, that's part of the problem. Minus 79 is 21, so 21 here. Okay, so given that, you can now answer these questions. How many people liked Indian and Thai food? That's this football, but didn't like Mexican food. Get rid of that one. The answer is 7. How many people didn't like any of the 3 foods? That's 21. How many people liked Indian or Thai food? Indian or Thai food. So you add these 6 numbers together. So that would be 25 plus 3 plus 5 plus 7 plus 10 plus 12, which is 28, 33, 40, 50, 60, 62. Another way of doing that would be, if you go back, previously we had 79 that were in all of these. So we take 79 minus 17. That also gives you 62. So the first part is filling out the Venn diagram. Once you have the Venn diagram, then you have to identify which area on the Venn diagram corresponds to these particular questions, and then you can answer the question. Again, the order is, if we have people liked everything, we put that in the middle. Then we look for cases where people like 2 out of the 3. Those are the footballs. And then you have to use subtraction. 12 minus 5, 7. That goes right there. 8 minus 5 is 3. So I'm subtracting the one that's in the middle there. So that's how you get 7 and 3. Sometimes if you've got 3 out of the 4 elements in a contributions to a particular set inside a circle, then you can use subtraction. So in this case, 40 people liked Indian food. So I knew I'd already had 3 out of the 4 taken care of. 7 plus 5 is 12 plus 3 is 15. that was 15, so this has to be 25 to add up to 40. Then I had to skip to this one because these two I couldn't, there were two things I didn't know instead of one thing. So this one is where you like two things but don't like the third. Those are these ones right here. So I could have said, 7 people like Indian and Thai but don't like Mexican. That would be 7. How many people like Indian and Mexican but don't like Thai? That would be 3. So that's kind of the way you'd get those parts. And then we could go back, and then once we got this element, we knew 3 out of the 4 of that, so I could use that. I could use this information to find the next one, and then the OR was the one I had to do last. So all these 3 things I want you to turn the test as a, this is for online people. For people who are taking it in class, for you to turn it in within by next week.